Hello. So guys, so our next question from the line 75 sheet is minimum in rotated sorted array. Okay, so we have done the search in sorted array. Okay, so it is basically the same type of question. So here also what we have to do is basically we have given an rotated sorted array and we have to find the minimum element in it. Okay, we don't have to use linear search because we have to write this algorithm in big of log n time, and linear search basically takes a big of n times. Okay, so we will simply use binary search here also. Okay, so the same approach that we have used in search in rotated sorted array. So let's check how we will do it. Okay, this I have written binary search approach. So here's the example I have taken. Let's check how many time it has rotated. Okay, so if I tell, then simply this would be the original array that would be, okay, the sorted array, and it is simply visible that it has rotated 3 times. Okay, rotated 3 times. So to get this okay, rotate 3 times to get this array. Okay, this. Okay, so let's check, but we don't have to basically need how many times it is rotated or something. We just need to find minimum in this rotated sorted array. Let's see how our approach will work. Okay, so if I write our main approach, basically our main logic would be to find sorted halves. Okay, sorted halves. Okay, this would be the our main concern. Okay, so if I take this array as example, so if I divide in sorted halves. Okay, so this is basically the left sorted part. Okay, if I write left sorted, okay, and here it is simply right sorted. Okay, okay, so if we got that if we are if we are here in this position. Okay, basically what I want to say is, if we got the sorted part. Okay, if we get that we are in left sorted part or in right sorted part, simply the minimum value of any sorted part would be the first value of that part. Okay, if we are in left sorted part. Okay, if we are in left sorted part and the array is sorted, then simply the first value. Okay, the first value will be the minimum, because if it is sorted, then simply minimum would be the first value. Okay, and if we are in right sorted part, then simply its minimum would be the just mid value or mid plus 1 value. Okay, simply you got the approach. Okay, so let's just analyze it more. Okay, so this is the array, and just take it, just remove this line. Okay, and just let's take, okay, let's iterate it with using low and high. Okay, so we will take what low. Okay, and high at last. Okay, and the third variable would be mid, that is always equals to low plus high divided by 2. Okay, let's calculate mid. So initially our low would be here and high would be at last. That's the binary approach. Okay, and mid is on the middle part. Okay, so what the approach is saying, that if we get any sorted part. Okay, so here we will check if is basically in which sorted part are we in. Okay, so how will this be checked? We'll simply check, is the low lower than mid, or the mid lower than high. Okay, there will be two conditions. Okay, let's okay, just wait. Okay, so there will be two conditions at this time where mid is on the mid. Okay, on this 5, basically at the mid, low plus high 1 2. So there will be only two conditions that could be possible. So to calculate left or right sorted part, main concern is only the left sorted part or right sorted part. Okay, if we get the left sorted or right sorted, we simply can say the leftmost element would be the minimum. Okay, because it is sorted. Okay, so let's check if array of low, basically at low the number is smaller than or equals to array of mid. Okay, if it is true, if the number at low is smaller than number at mid, then simply it is what? It is left sorted part. Okay, left sorted part. Okay, and the same condition we can say for else also. Else, that is, if array of mid lower than or equals to array of high. Okay, this is right sorted part. Okay, so simply what we say, if it is in right sorted, if it is in left sorted part, simply we can say answer would be array of low. Yes. Okay, and if it is in array of right sorted part, then the answer would be simply array of mid, because it would be the smallest element. Okay, so this is how this approach is work. Let's just write the pseudocode. Okay, so simply what we will do is we will take an answer variable. Okay, answer variable, we will initialize it with maximum value, that is int max. Okay, that is the maximum value of integer, and we will simply check, we will calculate the mid. Okay, let's take here and just take it to up, and this whole thing will continue till while low is smaller than equals to mid. Okay, so just okay, so we will calculate every time mid, and we will check if array of low, basically this part, this number is smaller than mid or not. Basically we will check if we are in left sorted part or right sorted part. If we are in left sorted part, we will simply calculate the minimum value for it. Okay, simply what we will say, minimum of answer and array of flow. Okay, and answer is the maximum value, so simply it will store the minimum value. Okay, and here also for right sorted part, we can same write here. Okay, so let's see the working of also. Okay, so I have written the pseudocode. So what we'll do is, basically first we will calculate mid equal to 2 plus high upon by 2. Okay, so mid would be here at 5. Okay, then what we'll do is we will check if array low is smaller than array mid. Okay, so here's the number at low indexed is smaller than, so what we'll do is, it is the left sorted part, and answer would be minimum of this answer and array of low, and answer is int max. Okay, so the maximum value, so the minimum will be 3 or int max, so the answer would be 3. So just let's just write here, answer would be 3 at first. Okay, so then what we have to do is, basically we just need to have written one thing, that then we have to move to low to next sorted part. Okay, so low to mid plus 1, because we have calculated the sorted part we have calculated the mid for this sorted part. Okay, left sorted part, then we have to simply move to the next sorted part. Then okay, simply what we'll do is low equal to mid plus 1, so simply move to this. Okay, then what we will, let's write here also. So if our answer is on, okay, if our answer is right sorted part, and we have found the answer in right sorted part, then we simply move to left sorted part. What we'll do is we will simply move high to mid minus 1. Okay, This is simply the movement. Okay, so let's calculate the next mid. So the mid would be low plus high upon by 2. So it would be simply, if I see 0 1 2 3 4, okay, 3 plus 4 7 upon 2, that is 3.5, and simply it will be 3. Okay, so the mid will come here at low position. Okay, so the mid is this one, and simply what we'll do is it will simply check minimum of 3 or 1, so simply it will update to 1, and simply at last low will becomes to and then what we'll do is it will simply move low to mid plus 1. Okay, so simply uh, it will low to mid plus 1, that is on high, and the loop terminates. Okay, and the loop will terminate, and it will simply give return, we will at last we will return answer. Okay, so just write right answer. Okay, so this is the code. Okay, I will provide you the code in GitHub also, and let's check the code in LeetCode also. Okay, so here's the basically code in LeetCode. So here's this question. First we have taken the low and high. Okay, low as 0 index and high as last index, and answer is equal to int max. Okay, simply we will iterate through the loop till low is smaller than or equals to high. Okay, we will every time we will calculate mid, that is low plus high by 2, and this is the basically what, this is left sorted part. Okay, if the answer is in left sorted part, then simply it will, what will the answer, the lowest number would be the nums low, that is the number present at lowest low index. Okay, and if this is right sorted part, okay, and the answer would be at mid index. Okay, because the lowest number would be there. Okay, because it is sorted. Okay, simply at last we can return answer. Okay, so let's check. So yeah, it's working fine. Okay,